Hello, General Biology, and welcome to the second screencast in the Section 4.3, Chapter 4 series. And we last left off, we were talking about succession, and we were just giving an idea of secondary succession, how that can happen after a fire. So in this picture, we see the fields at Carolinas Piedmont. This is kind of representing the Piedmont that had been abandoned. And over the last century, these fields have passed through several stages where they are now have in the forest matured oaks. This change took a long period of time, but just like we see here, started out with a few pioneer species that came in, and then we get different kinds of grasses and flowers and shrubs. We get a lot of spruce and hemlock that will start. They're usually the first plants to come, and then we'll see the oaks and the maples and the birches and the beeches and the ironwoods and all of those different types of trees starting to come in and fill up that area so that it winds up being a mature forest. So succession occurs because the environment changes. And the environment either changes due to organisms like humans or like dinosaurs or like bears or other organisms that live in the area. One of our models of succession kind of indicates that species can alter its environment, and when it does alter it, it makes it easier for other species to compete for the resources and be able to survive. So species can migrate in and change that, and we're seeing that with the Canadian geese. Lichens are going to be there to add the new organic matter that's going to be forming the soil. And then with that happening, you wind up getting mosses and other plants that are going to be able to colonize and grow. So as this organic matter accumulates, we get species that depend on that particular type of organic matter to move into the area and to start making that area a home. And that activity further changes the environment. So over time, as more and more species find the area suitable and they're able to live and reproduce, and they have their niche, we see that these areas will survive. Now, I'm going to tell you, on the test, I'm going to be putting this diagram. It's going to have a meandering stream coming down from the hillside, and you're going to see that there's trees and all sorts of things in this picture. And I'm going to ask you, what do you think would happen to this area if a dam was built? And I'm going to divide it into Area A, Area B, Area C, Area D. And I'm going to say to you, if a dam was built between Area da-da-da and Area da-da-da, what do you expect would happen? And I'm hoping that you're going to be saying, oh, well, Mrs. Saunders, it's going to move out some species. They're going to leave. They're not going to be able to survive. It's going to cause succession to occur in areas. It might dry up the river stream below and cause changes. What kind of changes? It's going to reduce the amount of flow of water, so organisms dependent on that are not going to be able to survive. Are we going to see primary succession, secondary succession happening? So be prepared for questions like that. Those are questions that are considered critical thinking questions. So when you're hearing this stuff, well, think, how can I use this? How can I apply this information? The next thing that we want to talk about is climax communities. And climax communities are those communities that we call the old growth forests that we think have reached their ultimate peak, and they seem to not have as many obvious changes. And as I said, they're still changing. They're going to continue to change. And we're going to talk about secondary succession in healthy ecosystems that follows natural disturbances that go on, and we'll take a look at ecosystems that may or may not recover from extensive human-caused disturbances. So climax communities are communities that I called an old growth forest. They're usually stable communities. Ecologists used to think that these areas no longer went through any changes, that succession no longer continued, but succession is always a continuing process, and it does produce these specific stable communities called climax communities. We know that when an area is pretty stable, that succession doesn't always follow the same path as we learned in primary succession and secondary succession. And we have also learned that these, what we think are stable climax communities, that they're not always uniform and stable. There's changes that happen within them. One of the causes of change could be a natural disturbance. We're seeing Hurricane Harvey hitting, and that is going to be destroying a lot of areas with the flooding, and it's a disturbance. It might be washing some of the soil away, it may be taking down some trees, but if the ecosystem is healthy, then it's going to be able to rebound very easily. One of the places that you might not think typical of succession would be a coral reef or a tropical rainforest. Coral reefs, if they're healthy, they'll recover very easily from a storm that comes through. If they're not healthy, then they're going to die out and they're going to bleach out. Healthy forests that have had periodic fires, grasslands that have had periodic fires, they're going to be able to bounce back. Now, with the one that I talked about in Gatlinburg, Tennessee, we're talking about 80 years or more of leaf and twig and dead tree debris that was piled up there. So there was a lot of fuel. That was an intense fire. So a bigger fire like that, it might take a little bit longer for those systems to bounce back. Detailed studies have showed that some climax communities are not uniform, that they have areas in varying stages of secondary succession because of the different disturbances that have taken place throughout the years at different times. So climax communities are disturbed so often that they can really be called stable. So if we do have these older growth forests, and maybe during one time there was Hurricane Sandy, but a few years back there was Hurricane Irene, you can see the damage that's left behind, but you can also see that it's picking itself up and it's repairing itself because it's able to go through succession. Ecosystems may not totally recover from extensive human-caused disturbances. When we talk about open pit mining, where we totally destroy the surface of an area, that might take centuries for it to be able to repair itself. I want you to take a look. I want you to stop this and take a look at pictures. Google pictures on open pit mining so that you can see what I mean by that. Or even look at mountaintop mining, where they cut off the tops of the mountains. And these are disturbances that are human-caused that these areas may never recover from, because in these two situations you're creating toxic sludge and toxic soil that may not be able to support a living system. So clearing and farming of tropical rainforest, this is a really good example because the soils in rainforest is very poor. So with that being so poor, when they cut down the trees, oftentimes they can't grow anything healthy on it. These can change the microclimate, they can change the soil, and enough to prevent regrowth of any of the original communities. So scientists study these patterns of succession so that they know how to repair areas that were disturbed. They compare different cases and they look for similarities and differences. In 1980, when Mount St. Helens erupted, researchers immediately went to study the Krakatoa so that they could get an understanding of how succession was going to come in and repair the area of Mount St. Helens. Both Mount St. Helens and Krakatoa primary succession proceeded through the predictable stages because there weren't any other disasters or things that were happening. The first plants and animals that arrived actually brought in seeds, and animals bring them in their fur and their feathers and spores, and then adult stages that traveled over long distances also came into the area. Hardy pioneer species helped to stabilize the loose volcanic debris, and that enabled other species to come in and take hold. So if we look at the historical studies of Krakatoa and the ongoing studies of Mount St. Helens, we can confirm that the stages of primary succession are very slow, and that that chance can play a large role in determining which species are going to colonize at the different times. Okay, that ends section 14.3, and we're going to get into 14.4.